Hey guys, welcome back to another day of Advent of Code, day number 7. Let's get started. The historians take you to a familiar rope bridge over a river, in the middle of a jungle. The chief isn't on this side of the bridge, though maybe he's on the other side. When you go to cross the bridge, you notice a group of engineers trying to repair it. Apparently, it breaks pretty frequently. You won't be able to cross until it's fixed. You ask how long it'll take. The engineers tell you that it only needs final calibrations, but some young elephants were playing nearby and stole all the operators from their calibration equations. They could finish the calibrations if only someone could determine which test values could possibly be produced by placing any combination of operators into their calibration equations. Each line represents a single equation. The test value appears before the colon on each line. It is your job to determine whether the remaining numbers can be combined with operators to produce the test value. Operators are always evaluated left to right, not according to precedence rules. Furthermore, numbers in the equations cannot be rearranged. Glancing into the jungle, you can see each elephant holding two different types of operators, plus and multiply. Okay. Only three of the above equations can be made true by inserting operators. 190, 10, 19 has only one position that accepts an operation between 10 and 19. Choosing plus would give 29, but choosing multiply or asterisk would give the test value 190. The engineers just need the total calibration result, which is the sum of the test values from just the equations that could possibly be true. In the above example, the sum of the test values for the three equations listed above is 3749. Determine which equations could possibly be true. What is their total calibration result? Okay, so let's get the puzzle input, guys. And let me create a folder for day number 7. Let's create one for part 1. I'm gonna save the puzzle input in here. And then, guys, I'm gonna also copy the example test they gave us. Right. And now, guys, let's start writing code. So, how am I gonna... First, I have to think about how I'm gonna be parsing each numbers from this thing. So, my idea is to read each numbers using fscanf. So I'm gonna include stdio. I'm gonna include ctype.h. I'm gonna include our list library. And guys, so I'm gonna have an integer called test value. We're gonna set it to 0. I'm gonna open the example.txt file. and we're gonna say while fscanf passing the file stream mod LLD. Wait, let's make this a long cause the maximum value, oh yeah, should be like a pretty big number, so we just parse each test value, and each test value is separated by a colon and a space, so we put that right here, and we say the return value of fscanf is not equal to the end of the file. Then we can just say, guys, so after that, guys, we're gonna need to read each number that comes after the test value. So we're gonna need to read 98, 139, 31, 2, and 66. So let's think about how we're gonna do that. So I'm gonna have a list, guys. Let's call it numbers. And guys, I'm gonna say, I'm gonna read a character at a time. So set this C to null. So I'm gonna say while C equals fgetC, f is not equal to the end of the file. And then what I'm gonna do is say if isDigit C, I'm gonna have an int for number. We're gonna set it to 0, and I'm gonna say number equals to number times 10 plus C minus 0. So we're converting each character from each number from its ASCII value into a single digit. And then we can say else if C is equal to a space, and we just skip that. Otherwise, if C is equal to a new line, then we just break out of this loop. And yeah, since each number is separated, each test values are separated by new lines. So right here we can just say, we can just probably set our number equal to 0. And then, guys, we can call list append numbers, passing our number, and right here we can just say list append numbers number, and let's do something like this, test value numbers, and call list print numbers, and let's see if our program is parsing our files correctly. 7. Let's go into challenge 1. Oh, this should be /example.txt. And now let's compile. Okay, I made a mistake right there. Alright, this should be numbers. Let's run the code. Let's see if it's parsing our example correctly. So we can see we get test value 190, numbers 1019, and we get 327, then numbers 814027. And yeah, it's extracting the numbers and the test values correctly, guys. So this means everything is being parsed correctly. So we're supposed to figure out what is their total calibration result. So this is the sum of the test values from just the equations that could possibly be true. Let me see something, guys. So if I open up my Python interpreter and I say 10 times 19 plus 81 plus, wait, hold on. Oh, I see, guys. So hold on, 190 plus 67 plus 292. Oh, so guys, once we find the equations, we essentially add up the test values, which are separated by colons, and then, but that is, we should only add them up as long as we find that whenever we insert a combination of the plus and minus symbols, we get the test values. So only if the equation can be made true. And operators are always evaluated left to right, not according to precedence. So this means we shouldn't do multiplication before addition. We should just do it in whatever order the operators come in. So I'm gonna have a function, guys, called bool find let's see, let's call it bool eval underscore test value, and we're gonna have a long test value, and we're gonna accept a list t of numbers, and we're gonna say, guys, so we're gonna need to get the combinations of each operators that can be placed in between each number. So this would be like 2 to the power of n minus 1, which would be the numbers length, or the amount of numbers, minus 1. So we could use the pow function, but I'm just gonna use the bitwise left shift operator. So this will be numbers.length minus 2. So I'm gonna say for size t I equals 0, I is less than 2 shifted to the left of numbers.length minus 2, I plus plus. I'm gonna say int temp equals to I for size tj equals 0, j is less than numbers.length minus 1. Let's do a printf numbers dot array index 0 right here, numbers dot array j plus 1. Guys, we can just say temp divide equals to 2. We're gonna say char let's have a list of operators. So this is gonna be a char pointer operators is equal to plus and multiply. And we're just gonna say operators at index I, let's say j mod numbers.length and let's see what we get, guys. So what I'm gonna do is say eval underscore, call the eval test value function, it's gonna accept our test value and our numbers. Now let's see what we get, guys. Okay, I need to include std bool and let's compile our code. So guys, you can see, wait, we have plus, minus, hold on. Oh, this should actually be the length of our operators. Say operator count equals to the length of our operators string. Then we can just say j modulus operator count, and let's rerun our code. Alright guys, so now you can see we are inserting operators in between our numbers. Oh, I'm doing something wrong, guys. This should be temp. So now we have multiple combinations of operators being inserted in between each of our numbers. So you can see we have plus, minus, then multiply, and so on and so forth. Now, all we need to do, guys, is evaluate each one of those combinations. So, here's how I'm gonna do it. I'm gonna have a long result. We're gonna set it to 0. And then, guys, I'm gonna say, wait, let's make our result be here. So long result equals to numbers dot array index 0, and we're gonna do a switch statement on our operator. We're gonna say if our operator is a plus, then we're just gonna say result plus equal numbers dot array j plus 1. Otherwise, if our operator is a multiplication symbol, then we're gonna say result times equal numbers dot array j plus 1, and we just break there. And then, guys, whenever we exit this loop, we're gonna check if our result is equal to our test value, then we just return true. Otherwise, if none of those equal to our test value, then we just return false. So then guys, I'm just gonna say if eval underscore test value returns true, then I'm gonna have a long called total calibration. We're gonna set that to 0, and total calibration will be equal to our will be plus equal to our test value. So then let's run our code. Alright, so what I need to do guys is print out the total calibration result. Total calibration is total calibration, and let's see what we get. So we get 3,749. Okay. So now guys, all we need to do is test it on our puzzle txt, and let's run our code. So we get this big number for our answer. Let's try to submit that, and we got a gold star. Now let's continue to part 2. First of all, let me create a new folder. For challenge number 2, and create a solve.c file. Wait, I don't need to create it. What I'm gonna do guys is copy our challenge 1 solve.c, and we're gonna modify it for our challenge number 2. So let's see what they say. The engineers seem concerned the total calibration result you gave them is nowhere close to being within safety tolerances. Just then you spot your mistake. Some well-hidden elephants are holding a third type of operator. The concatenation operator combines the digits from its left and right input into a single number. For example, 12 or concatenates 12, 3, 4 would become 1, 2, 3, 4, 5. All operators are still evaluated left to right. Oh, so let's say we get these two numbers, guys. So we have 15 and 6 for this test value. Then we try to combine them together. Okay, I see. And if when we combine them, guys, it is equal to our test value, then that means our result is true. Okay. And then we just need to print our total calibration result. Let's see. So it says adding up all 6 test values, the 3 that could be made before using only plus and asterisk plus the new 3 can now be made by also using this concatenation symbol. Okay, produces the new total calibration result of 11387. Oh, so let's try to solve this, guys. So guys, before I actually solve this, I'm wondering if, like, when we combine these numbers, if it would fit in a 64-bit integer. Just let me scan through these real quick. Alright, it probably will fit. So let's solve the problem. So first of all, we're gonna need to get the length of the number we're combining. So I'm gonna create a function called getNumberLength. It accepts an integer. We're gonna say int length equals to 1, so that's the initial length, and while the number is greater than or equal to 10, we're gonna increment the length, and we're gonna keep repeatedly dividing the number by 10 as long as it's greater than or equal to 10. And then at the end, we just return the length. So, let's see now. So I just realized I made a mistake right here, guys. So let's make this a size t10. So this will be numbers dot length minus 1. We're gonna have an int. Let's call it total combinations. Let's include our math.h library. So total combinations will be the operator count raised to a power of the amount of numbers minus 1. So n minus 1. So pass that in. And then, guys, we're gonna replace this with total combinations, and let's replace this with n. And we're gonna introduce another operator in here, guys, which will be our concatenation operator. And we're gonna have a case for right there. And right here, guys, where we're dividing this temp by 2, we're gonna actually divide it by the operator count. So then now, guys, we're just gonna say our result is gonna be equal to the result multiplied by our number length. So we're gonna say let's say int number length equals to get number length, and then our numbers that array index j plus 1. And we raise 10 to a power of that number length. And let's wrap this in parentheses. And this will be plus numbers that array index j plus 1. And let's test it out. So gcc solve.c. Well, I need to link with the CMath library, and let's execute it. So we run it on our example, and we get the same result. So let's now run it on our puzzle. And let's see what we get for a result. Okay, it's taking some time. Alright, so we get this for our answer. And let's try to submit that. And we got a gold star. So I'll see you guys soon for day number 8. Thank you guys for watching. Hit the like and subscribe button. Until next time, thank you all.